Alrighty, so wanted to go over how to interpret and how to understand your shapers to maximize print quality. Um, these graphs that I'm going to be using as examples are generated on a K1 Max that was rail converted. User's very happy with the print quality that he's getting now, so I thought I'd use it as a great example. Because although the shapers don't look great, print quality looks fantastic. Um, so first things first, you gotta match your belt tensions. Use an app on your phone, match tension between your A and B belts. You could run the belt calibration tool, whether through Guppy or through Clipane, ShakeTune. Once you've done that and they look pretty good, right? This is a 94.1 similarity for belt frequency. That's really good. Anything above 90 is considered great. So if you get above 90, you're on the right track. I'm going to close out the belts now. Once the belts are all done, you can go through and do your normal X and Y shapers. Do it through, again, Guppy, Clipane, do the normal clipper stuff as it is. Something I do want to point out is, yes, these three extra humps here are going to throw your suggested shapers way out of whack. We're going to ignore the suggested shaper, and I'm going to show you why. When you use a calculator, I'll pull up the calculator here. We know we ran this at a Excel per hertz of 100. Whether it be 75, 100, doesn't matter. Frequency is at an all-time low, or sorry, the vibration is an all-time low at a frequency of 75. So we could basically eliminate these three humps if we just never printed above here. So to know where that threshold is, right, we know we were at 100 Excel per hertz times our hertz at which that clip is, which in this one is 75. That means as long as you're not printing your outer walls above 7500, you're never going to see any of this junk that's on the back end. So we can treat it as if it's almost a perfect graph with a single hump. And we can do that either by running our shaper only to where that threshold is, or we can go ahead and just interpret it ourselves. And what I normally do is when you're looking at just a single hump, ZV is usually almost always the best shaper. But I like to provide a little bit broader of a spectrum. So I either use EI or MZV. In this case, we're going to use MZV. But we're going to center the MZV at the same peak that the ZV is identified for best smoothing. So when in your printer configuration, you're going to set your X axis shaper to shaper type to MZV, but we're going to use the frequency for ZV. So shaper type is going to be MZV, shaper frequency is going to be 46.2 or whatever's in this ZV category. That'll center the MZV first hump over this right here. That'll really, in a situation like this, would result in a vibration of 0%. We're going to ignore what the suggested accels are. Suggested accels, pretty much we already know, nothing above 7500 is great for outer walls. Y is a similar story. We don't really care about this. We know that ZV is centered over this hump for minimum vibrations. We know MZV is going to give us a better vibration calculation. So that's exactly what we're going to do. We're going to use MZV as the type and use this ZV 49.6 hertz for the frequency on the y-axis. Once we've done that and we understand that our outer walls are pretty much going to be printed somewhere in the lower range here, you could do it kind of between where the two peaks are, where the smoothing is going to happen. For this example, I had the user set 5,000. Upon further, looking at this, I probably would have drifted closer to 60, 65, because that's where the shapers are really doing the bulk of the work. down here. But for this example, 5,000. So we've gone through, done our shapers, done our bell tension. Next thing is either to print a VFA tower or use the vibration measurement tool in Clipane. The vibration measurement tool will map out speed versus vibrations, basically, or PST energy. And what it does is it slowly does, because we're testing ABXY as our axis, it's going to do a square and a cross to isolate each individual motor plus the movements for X and Y. And that'll generate a plot in which it tells us where we should ideally run. Pretty much anywhere in the green zone, the graph is telling us is fine to run. Of course, the lowest vibrations here on the graph are right about here. So knowing what we know now, if we're going to set our outer wall velocity or acceleration at 5,000, we're going to want to print at a speed right around 150 millimeters per second. So when you go to your slicer, you're going to set this outer wall acceleration to the acceleration that you did your sweep at, the one that showed the lowest the lowest impact on the shaper graphs, and you're going to also set that outer wall to the value that you found from your vibration graphs, or the speed at which the VFA was the lowest on your VFA tower at 5,000 Excel. Once you've done that, go ahead and print something out, see how you like the quality, but I can almost guarantee it's going to be better than using the suggested shapers. Hope it helps. Thanks.